Welcome to another video by Adeptus Academy. Light. It's the very essence of our ability to see, to perceive the universe around us. But what we perceive as plain white light is actually a breathtaking symphony of colors, a spectrum of wavelengths, each carrying its own unique energy. This is the electromagnetic spectrum, and it's more diverse than a cosmic rainbow. From the longest radio waves, stretching across the cosmos, to the shortest, most energetic gamma rays, the electromagnetic spectrum bathes us in its invisible glory. We humans only see a tiny sliver of this grand spectrum, the visible light that paints our world with rainbows and sunsets. But the unseen portions of the spectrum hold their own marvels, secrets whispered in wavelengths beyond our immediate perception. Unveiling these secrets has revolutionized our understanding of the universe and fueled countless technological advances. By harnessing the power of the electromagnetic spectrum, we've illuminated the unseen, communicated across continents, and peered into the heart of matter itself. What other mysteries await us in the wavelengths yet to be fully explored? Let's dive in and discover the wonders hidden within the light spectrum. We're all familiar with the vibrant colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. This visible spectrum, however, is just a tiny fraction of the electromagnetic spectrum's vastness. Beyond the red end of the rainbow lies a hidden world of infrared radiation, invisible to our eyes but detectable as heat. Infrared is everywhere, emitted by everything from the warmth of our bodies to the distant stars twinkling in the night sky. On the other side of the visible spectrum, past the violet, lies the ultraviolet UV realm. UV radiation is what gives us a suntan, but it can also be harmful in high doses. Beyond UV, we venture into the even more energetic X-ray and gamma-ray regions, used in medicine for imaging and treatment, and also bombarding us from the depths of space. Each of these wavelengths interacts with matter in unique ways, offering a different lens through which to view the universe. By understanding these interactions, we can develop technologies that harness the power of the spectrum for our own purposes, revealing a universe far more fascinating and complex than our eyes alone can perceive. Let's start with infrared radiation, a true technological workhorse. You may not see it, but you interact with it every day. That TV remote control in your hand, it communicates with your television using pulses of infrared light. The heat you feel emanating from a warm stovetop? That's infrared radiation too. Infrared technology is also crucial for night vision devices. By detecting the infrared radiation emitted by objects and people, these devices allow us to see in the dark, a capability once relegated to the realm of science fiction. But infrared's applications extend far beyond entertainment and security. Scientists use infrared telescopes to peer through interstellar dust clouds, revealing the birthplaces of stars and planets. Meteorologists rely on infrared satellites to track weather patterns and predict storms. And in medicine, infrared imaging helps diagnose a variety of conditions, from inflammation to cancer. Now let's talk about the speed of light. Light travels at an astonishing 299,792,458 meters per second, the fastest anything can travel in the universe. This speed limit, imposed by the very fabric of space-time, has profound implications for technology. Engineers are constantly striving to create faster and more efficient devices, and the speed of light is the ultimate benchmark. Fiber optic cables, for example, transmit information as pulses of light, allowing for incredibly fast data transfer rates. This technology has revolutionized communication, making instant global connectivity a reality. But the quest to harness the speed of light doesn't stop there. Researchers are exploring new ways to use light itself for computation, creating optical computers that could potentially operate millions of times faster than traditional electronic computers. Imagine a future where complex calculations that currently take hours or even days could be completed in a fraction of a second. Remember those night vision goggles we mentioned earlier? They're a prime example of how we can manipulate the electromagnetic spectrum to enhance our senses. Night vision devices work by capturing the infrared radiation emitted by objects and converting it into a visible image. Every object with a temperature above absolute zero emits infrared radiation. The warmer the object, the more infrared radiation it emits. Night vision devices use specialized sensors to detect this radiation, even in complete darkness. The sensors then amplify the signal and convert it into an image on a screen, allowing us to see in the dark. This technology has revolutionized military operations, search and rescue missions, and wildlife observation, allowing us to navigate and understand the world around us, even when our eyes alone fail us. Now let's venture into the realm of science fiction, or is it? The idea of an invisibility cloak, once confined to the pages of fantasy novels, is now being explored in research labs around the world. While we haven't quite achieved Harry Potter levels of invisibility just yet, scientists are making remarkable progress in manipulating light to render objects invisible. The key to invisibility lies in bending light around an object, making it seem as if the object isn't even there. This seemingly magical feat can be achieved using materials called metamaterials, which are engineered to have properties not found in nature. Metamaterials can interact with light in unusual ways, bending it in ways that defy our intuition. By carefully designing the structure of these metamaterials, scientists can create cloaking devices that can render objects invisible to certain wavelengths of light. While a true broadband invisibility cloak that works across the entire visible spectrum is still a long way off, the progress made in this field is nothing short of astonishing. The exploration of the electromagnetic spectrum has already yielded countless technological marvels, from medical imaging devices to wireless communication systems. But we've only just begun to scratch the surface of this vast and fascinating realm. The future holds even more exciting possibilities, limited only by our imagination. Imagine a world where we can harness the power of light to create ultra-efficient solar panels, wirelessly transmit energy over long distances, and develop new forms of communication that operate at speeds we can only dream of today. The electromagnetic spectrum is a treasure trove of untapped potential, waiting for us to unlock its secrets and shape the future with its power. As we continue to delve deeper into the mysteries of the light spectrum, we're bound to uncover even more astonishing phenomena and unlock technological advancements that will shape the future of humanity. The journey into the light has just begun. The universe is awash in light, a symphony of wavelengths constantly bombarding us from every direction. From the faintest whispers of the cosmic microwave background radiation to the blinding brilliance of exploding stars, light carries with it the stories of the universe, past, present, and future. By understanding the language of light, we unlock the secrets of the cosmos. We can trace the evolution of galaxies, study the birth and death of stars, and search for signs of life on distant planets. The electromagnetic spectrum is our window into the universe, a tool for exploration and discovery that has revolutionized our understanding of our place in the cosmos. So the next time you gaze up at the night sky, remember that you're looking at a tiny fraction of the universe's light show. Beyond the reach of our eyes, a vast and invisible realm awaits, filled with wonder, mystery, and the promise of countless discoveries yet to be made.